Hello geometry. So this short video is going to be about midpoints and the distance formula. So we're going to start off with looking at midpoints. So the midpoint of a segment, by definition, it divides that segment into two congruent segments. So it divides a segment into two congruent, start to use our notation, segments. So how that would look is if I have a segment here, here is A, here is B, M is between A and B, and if M is the midpoint, we know these two segments are going to be congruent. So we have an actual theorem or definition. Definitions work both ways, but we have a precondition. So we have that A, M, and B are collinear, and another precondition is M is between A and B. So setting that up, then we can start with our definition. We know M is the midpoint of AB, segment AB, and I'm going to abbreviate this IFF. This means, I'll write it this time, if and only if, because all definitions work two ways. If and only if AM, the length of AM equals the length of MB. Remember, without a line, that's what that means. It's also equivalent to say that segment AM is congruent to segment MB. And we can read a definition backwards. If you know AM is equal to MB, then you know M is the midpoint, again with the preconditions. Okay? So, kind of obvious. If you have a midpoint, it's a halfway point. It's in the middle. A segment bisector is something that cuts that segment in half. And a segment bisector can be all kinds of things. It could be a ray coming off of it. It could be a line that goes through that midpoint. Anything, so it's basically any shape that could be a point, it could be a ray, it could be a line segment, that intersects the segment at the midpoint. The segment at its midpoint. All right, which kind of makes sense. A segment bisector is something that goes through the middle of the segment. All right, so in this example, and again, when you're watching a video, sometimes if you want to pause the video and try the example out on your own, that's not a bad way to kind of make this a little more interactive. So on example 1, you want to state the bisector of segment EF and then find the measure of the whole thing. So in this case, the bisector is going to be a line, and that is line M. And now to find the measure of it, well, since it is a midpoint and we have these congruent symbols, we know that x plus 15 has to equal 7x minus 3. So unlike your segment addition property, we're not adding the two segments together and setting equal to the whole. We have the information that each segment is equal, so that's how we set up our equation. And we go through and solve, subtract x from both sides, add 3 to both sides. So we get from that x equals 3. And since we want to find not just what is x, but what is the length of that segment, the measure of that segment is going to be 3 plus 15 is 18. So it's going to be 2 times 18, which is 36. That would be the measure of the whole segment. Okay? So, midpoint formula is if you are given the information as a coordinate, you are going to need to find what that midpoint is. So since it is a halfway point, if I have two coordinates, x1, y1, and x2, y2, so that represents two separate points, the midpoint since it's a halfway point, is an average. So you're going to add the two x values together and then divide by 2. You're going to add the two y values together and divide by 2. So if you're using the midpoint formula, that is how you would use it. So here we have an example 2. And again, if you want to pause and try these examples, that's a good way to do this. We know the endpoints of RS, and again, I always like to draw a little diagram. Here's R, here's S. This is 1, -3, and S is 4, 2. We want to find the coordinates of the midpoint. So we are going to call that point M. So we add the x values, divide by 2. We add the y values, divide by 2. And so we get 5/2, or 2.5, I really don't care, and -1/2. And that would be the midpoint. Now the harder version of this is, and I didn't give ourselves a lot of room here, is if we are given the midpoint and one endpoint, and we have to find the other endpoint. So in a problem like this, I'm going to have to draw it over here because I didn't give us a lot of space. We are given the midpoint here is 1, -2. That's our midpoint. One endpoint, J, is at 7, 2, and our goal is to find the coordinates of this other endpoint. Okay, I don't like to do this kind of a problem on using a formula because I find formulas, it actually is a sophisticated algebra problem to solve. I think it's stronger to kind of reason it out knowing we know that M is the midpoint. So let's talk about what's happening. So to get from the x value of 7 to the x value of 1, I had to go down 6. I had to subtract 6 to get from 7 to 1. So since that's a halfway point in the x coordinate, I have to go down the same amount. So 1 take away 6 puts me at -5. Now let's do that for the y value. To get from 2 to a -2, I would have to subtract 4. And did I have the right coordinate? Yeah. To get from -2 then, I have to go the same distance, so I'm going to go down another -4. So -2 minus 4 puts me at -6. That would then be the other endpoint. All right, to actually solve this as an algebraic equation, you're going to have to do a lot of distribution and cross-multiplying. I find just reasoning it out actually an easier way to go because you know the midpoint's halfway, so you have to go the same addition or subtraction that you did to get from one endpoint to that midpoint. All right, we'll have a problem like that in the CFU, so you can get some practice with that. Okay, distance formula. Distance formula is basically, now you saw that distance between 2 points, if it was horizontal or vertical, is going to be just subtraction. But what happens when that distance is not horizontal or vertical, but something, let's say, like this? So what we can do, there's 2 ways to do this. You could do it, notice you can kind of make this triangle, and what you're really doing is Pythagorean theorem. That's what the distance formula is. Formally, if you have 2 points, here's our x1, y1 again, and point B, so let's say this is A and this is B, is at x2, y2, the distance between those points, because remember in Pythagorean theorem you always have to take the square root at the end, a squared plus b squared equals c squared, and you take the square root. Well, to get the length of your legs, this goes back to what you guys did when it was horizontal or vertical. How do you get that distance? You subtract the points. So this would be, and it doesn't really matter the order because you're going to square it. So x2 minus x1, that gives me this length. And then y2 minus y1 gives me the other length. And voila, you would have the distance formula. Okay, so if you actually have a graph, you have a choice. You can actually just find those lengths and do your distance formula, or do Pythagorean theorem, because that's really what distance formula is. So here we have an example. Again, if you want to pause and try this on your own, that might make it a little more powerful. So I'm going to go ahead and graph. A is at 2, -4. B is at -3, 4. So here, I'm going to go ahead and connect that dot. And I'm going to go ahead and kind of draw in our triangle. So, oops, I didn't go down far enough. Let me erase that little mistake there. Okay, so this needed to go down a little bit further. Okay, I'm going to do it as just straight up distance formula first time, and then we'll see how you get the same answer if you just do Pythagorean theorem. So I always like to write down kind of the template. The template is your a squared plus b squared. How do you get that a squared? You have to subtract. So first I'm going to subtract my two x values. So this is going to be 2 minus a -3. And then I'm going to subtract my y values. So this is going to be -4 minus 4. And then we simplify this. So this becomes 2 plus 3 is 5 squared. And this becomes -8 squared. And that gives me a lovely square root of 89, which cannot be simplified. Later on, you are going to have to simplify radicals, but there you would go. Or you can get a decimal answer, which you might want to use a calculator for those then. But let's see if we had done this as Pythagorean theorem. So what is the length of this leg? Well, I could just count 1, 2, 3, 4, 5. Notice that's 5. And then 1, 2, 3, 4, 5, 6, 7, 8. There's that length is 8. And you would then just go 5 squared plus 8 squared. Remember, you're trying to find your hypotenuse, so you also have to take the square root, and you get exactly the same answer. So if you have a grid, it actually makes it really nice. Okay, that is our video for 1.3. There's a little check for understanding we would like you to complete during this period, just to make sure you get the concept. And I hope you guys have a great rest of the day.